Well, I want to thank you all for sticking around this late. I know it's been a long 2 days, but an exciting 2 days. So the work I'm going to talk about today, there were a number of authors on this paper, and I show you this slide to give you a sense of the diversity of knowledge that comes out of these people, from computer programmers to UI UX specialists in terms of designing software, to global thought leaders, and finally to people who are experts in market research. I sort of took all of those people and me as a data scientist to come together in order to make this paper happen. So I think you're going to like to actually see some votes from real people on QV. So let's start. So I was at the SeaTac airport a few weeks ago, and after I used the bathroom, I came across this. And I thought, you can't even go to the bathroom these days without being given a survey. And what we have here basically is their attempt to determine your bathroom experience. And it sort of reminds you how ubiquitous the survey has really become in our society. So, I mean, you see them in bathrooms, and obviously market research, business, democracies, education. So surveys are everywhere now. And one important question that I care about really is, how accurate are those data that we're getting from these surveys? And there's this goal, this idea that it's reflecting back how people really feel. But there's a question of, that the quality of that reflection is embedded in your methodology. And so I'd like to look at two different methodologies today and see how well they reflect back those preferences. So we'll start with Rensis Likert, whose 1932 dissertation gave us what we all know now is the Likert scale. And Likert had this idea that we should be using this kind of scale in some pretty significant situations. So he cared about things like international relations and race relations. So his Likert scale was not intended for bathroom surveys. It was intended for serious issues. And we're going to see political issues today is the topic of this talk. Now, what's interesting is if you look at market research and what's being done there, the Likert scale is still basically the most important tool that's being used and extremely common. And there's been a lot of research on Likert, and I'll just give you a few little thoughts here so you can see what's going on. One nice thing about Likert is that results are stable over time, assuming preferences are stable over time. So they don't just randomly put down numbers, they sort of tend to give the same results, which is something you would want in a scale. And then also we see that the ends of the scale are somehow more meaningful than the middle part of the scale, which is another feature you would want on your scale that you just sort of assume is there when you create it, but isn't necessarily true. Now, there are a lot of problems with Likert, and one of the biggest problems is it tends to only be good when people really care about what's going on, which is one suggestion that maybe putting it in the bathroom is perhaps not such a great idea. Let's look at this other one that's even worse, in fact. Typically, when you take a Likert study, the issues that you vote on are all sort of decoupled. That is, that your vote on one proposal has no influence on your vote on the others, or doesn't have to. And it's also decontextualized. So if someone says they really care about some new proposal that's going to cost a lot of money, well, that's great, but maybe they haven't really thought about the budget, or they know nothing about the budget. So we tend to have people vote on things very decontextualized, which is perhaps not the best idea. And so one of the reasons I like QV as an alternative is that it sort of addresses two of those main issues. So let me tell you two things that I notice about QV as a data scientist. I really like the idea of having a cost to strong voting. So we can put the same Likert scale here, but as soon as we put a cost on it, now suddenly it's a QV scale. And we'll see that there are a lot of benefits with that tiny little change. And the other is that you can actually couple all the issues together by giving a credit bank. Here's 100 credits. Artificial currency will be what we talk about in this instead of real money, which is an important difference. Okay, so we've heard a lot of talk about theory, and there's been a lot of work on the computer side in terms of showing the value of QV. But what's challenging is that we know people are not perfectly rational. They're far from perfectly rational. So while QV has proven to optimize collective decision-making under certain mathematical assumptions, and while it's also proven to be valuable in certain statistical simulations, there's a question of what it really does in the wild. And that's what we're going to look at. And so you might say, well, why is there any hope for this working in the wild? And so here is some research. There was a nice book by Mullynathan and Shafir, And they argue for something called the scarcity mindset, which is anytime you have a scarcity of something, it can be money, it can be time, it can be resources, it can be friends, that the way you approach the world in your thinking is fundamentally different than when you don't have that scarcity. And so one of the troubles with standard surveys is people are not given any kind of scarcity environment. And what's interesting is in the real world, almost every decision is made in a scarcity environment. So we want to reflect back people's opinions, but we're reflecting them in a way that doesn't represent reality. Okay, so here are some nice principles that scarcity brings. It actually reflects the reality that we make decisions in. It causes people to actually make reflections. And it decreases the reflexivity to just, oh, I choose that. They actually have to be far more thoughtful when scarcity is present. And one nice thing about scarcity is you can get the scarcity mindset that they talk about through artificially constructed scarcities. For example, if you have a computer video game and you're not given much arsenal to fight enemies, they notice exactly the same effects of scarcity with artificial currency than they do what they see with real currency. So let's talk about the study that we created in order to explore. So we contracted with someone named Taluna. This is a survey sample provider. They bring you people, and they brought us 5,000 people. And they were sent over to collective decision engines, and we randomly assigned them to one of three conditions. Okay, so the first condition, we have a bunch of people that are going to take a Likert survey. And I'll show you that survey in a moment so you can see what the issues were. The next group took QV, and then we had people actually take both. And they did Likert and then QV. And so this provided a nice opportunity to compare the same methodologies in the same human beings. Okay, and here you can compare across human beings. And if you want to know what kind of people they brought us, basically they reflected the age diversity of the US, the gender distribution of the US, and on most other demographic variables, they looked roughly like the US. Okay? The point of this was not necessarily to generalize and figure out how the US cares about things. It was mostly a methodological comparison, but in some sense it had some truthfulness to what America actually feels. Okay, so we weren't pulling out some random strange group of people and showing the methodologies were different in those two random groups. Something that market researchers care about is the completion rates of these. And it's sort of nice to see that people can complete QV at roughly the same rates as they do Likert. You might worry that there's such a cognitive demand on QV that everyone would walk away, but it's simply not true. Okay. So here were the 10 issues. If you don't want to read all the words, you can read the bolded words, which basically give you the ideas of the important proposals here. And I don't really care about the proposals. You can ask them about anything as far as I'm concerned, as long as it has important characteristics. So these are all things that people tend to feel quite strongly about. They tend to be issues that are in the media today. For example, at the end, you can see we ask about Syrian refugees, which is very topical. And importantly, the questions are devised in such a way that your textbook Republican or textbook Democrat would not just vote one side of the scale. They would not use all positive rankings, because some things are reversed from the orientation that they would want to see. Okay, so you really have to be thoughtful in using this survey, and you can see it has quite a diversity of issues. So we have these three conditions, and rather than talk endlessly about what they all look like, I thought I'd show you a video of the experience that people went through. I'll show you the Likert QV, because this has all the components of what people saw. So let's take a look at that video. So at the beginning here, we basically have a screener question to make sure that people are old enough to vote. So we only want people who are 18 or above. Okay, so after that, they're given some introduction. And once they get through the introduction, they start voting on the Likert scale first. You'll notice we have a 7-point Likert scale here that goes from very strongly against to very strongly in favor. They select a radio button, and they move on to a new issue. They continue to do this. You can move backwards and go back and change things if you want, and you're simply selecting radio buttons and slowly progressing through the survey. Now, after you've moved through all 10 of these, you're then going to transition into the QV portion in which you'll have the same issues. Now, because people were unfamiliar with QV, we decided to have a short video that would introduce them to the ideas of QV. Okay, so this is the CEO of Collective Decision Engines talking about the software, giving some helpful pointers on how to use it, so they would have some understanding of what was about to happen. After watching this video, which is about 1.5 minutes, they would move on to the QV portion. And you would see here that we give them some rough idea. You're going to have this many credits. Here are how many proposals across which you must split them. And here's some advice on how to use QV and not blow things up. Now, you'll notice in the QV survey, there's some important differences from Likert. The first is that you use plus and minus buttons to slowly move up. And here we have a vote range from -10 to 10. As you're casting these votes across the top, you have a credit bar which will decrease quadratically if you stay on the same issue. You can vote for or against, and it's simply a bunch of thumbs up and thumbs down getting you to your votes. You also notice that all the votes appear on the same screen, and you simply scroll up and down to move between them instead of forward and backwards buttons. After completing this, we wanted to know about their experience. So we started with a question here, 0 through 10, give us your overall feeling. And then there was a spot for qualitative feedback, where you could type in how you felt. And you had to type something in order to move on. Okay, so they typed something in, they hit next, and then we move to a series of demographic questions. So the ending here starts with these sort of opinions about things, and then we have demographic stuff. And these are the major demographic categories of gender and age. And here we're using sort of traditional brackets for how you sort of define things according to the census. Now here's the political affiliation, which will be important. You'll see we have these 7 major affiliations, 3 kinds of Democrats, 3 kinds of Republicans, and then an independent in the middle. And then we move on to race, and we have our final categories of where people live. And so this is me just randomly selecting things in this demo here, how much money you make. And finally, an important thing, which I'll call checkboxes and refer to later, people were asked, you just saw these 10 issues. On which of these issues would you like to get more information so that you could go influence policy? And you can check as many as you want. You can uncheck them. And once you hit next, you're done with the survey. And at the completion of the survey, people were given a code that they would take back to Toluna. From that code, they get Toluna points, and they can buy things. So they're incentivized to complete the whole thing so they can go back to Toluna with their code. So that is basically what this experience looked like in the largest condition where they had to do the most things. And you can see there are a lot of kinds of data that come out of this. And as the data scientist, it's quite overwhelming. First of all, you have the final vote allocations. You can convert the Likert 7-point scale to -3 through 3, which is a pretty standard practice. The QV scale was -10 to 10. These are all integer values. There was no way to get any sort of fractional values. We also have the vote metadata. Okay, we tracked every single action they took. You know, how long did it take you to press that radio button? Did you press another radio button on the same screen before you moved on? So every single action was logged, and you have time data. Finally, we have, at the end, those user experience, both quantitative and qualitative, and those demographic categories that you could then go explore if that was something that mattered to you. And finally, these checkboxes, which will be important at the end. Something interesting about these checkboxes, these are people who have signed up with Toluna. And Toluna has their email address. It has their whole life. So for them to check this box, they might be quite worried that something real is going to happen, that they're actually going to start getting emails. Okay, so this is a pretty powerful thing for someone to go and check one of these boxes. So just as an overview of what the 3 conditions did, you can see here, and there are commonalities. You know, they all end with the experience demographics and checkboxes, and they all begin with the screener and welcome questions. And the only thing that differs is what happens in the middle. Okay? And those people that need to do QV need to have a short little video tutorial. Okay, so let me tell you about the different results that came out of this. I want to do this in sort of 3 phases. First, give you a sense of globally what happened if you look at the votes, because it's a pretty powerful result that might be striking. And then I want to dig down into individual voters to try to understand where those global results are really being born from. And finally, what market researchers care about is the predictive power. Is one of these better in some sense than the other one? So on the global landscape, we can take some issue, for example, paying women equally or banning abortion, and you can just create a histogram of what kinds of votes you got out of this process. And you know, the percentage that fell into each of the bins. And these distributions are very common for Likert distributions. Okay, you get a lot of skewed things toward one end when it's an issue that people basically feel quite positive about. And then you also get things that start to look like W shapes where people take extremes. And then there's some neutral in the middle. But things like votes like 1 and 2, people aren't really excited about giving those because why not just give a 3 if you're going to give a 1? okay, that people are not very good at self-moderating. Now, if you look at the same issues in QV, you get a radically different picture. And basically what you have are beautiful, or almost beautiful, normal distributions here. So what we've basically done is sort of terraformed the whole voting landscape, and now we have this new world which, in some sense, you might even hope for a normal distribution. That somehow this almost feels quite misrepresentative to me. And I know people will disagree, but I like the fact that you take a process and you normalize it, because there are a lot of properties statistically that you would that are nice to have with a normal distribution. And you can look at this using statistical measures of skew and excess kurtosis, which are just ways to sort of measure how much something looks like a normal curve. Okay, so the skew is simply a measure of symmetry. Can you fold it across a vertical line and land back on itself? So a skew of 0 means it has perfect symmetry. And you'll notice that most of these skew values are decreasing in absolute value. Okay, so these things are becoming more symmetric. Whatever the distribution looked like before, now it's more symmetric. And excess kurtosis gives you an idea of the tails of the curve and if they look like a normal distribution. So an excess kurtosis value of 0 is something that is a perfect normal distribution. And you'll see here that these QV excess kurtosises are much closer to 0 in absolute value in almost all cases. So you're basically creating something that is sort of normal on the tails of the distribution. So these are sort of numerical ways to, which you see instantly in the picture to sort of back that up. Now the question is, why on earth is this happening? And one answer, there are many answers to that, but one answer is that people are sort of totally changing the way that they vote, that the way they interact with those proposals. And I want to look at just some general summary statistics to give you a sense of how people are differing. So you might ask, how long does it take to use each of these methodologies? A very obvious question. And we have these groups that just did one of the methodologies, and here we have over a minute, and the QV people are taking roughly 30% longer. And you can take the people that did both, Likert and then QV, and you can say, well, how long did you spend on the Likert? And how long did you spend on the QV? And they're still taking longer. And what's interesting here is this is not what you would really expect. I mean, if they're doing both, when they do the Likert, they see the questions for the first time. They process them. They think about them. They decide how they feel about them. And when QV comes around, you would expect that it wouldn't take so long. And yet they still spend longer when it comes to QV. So somehow they're engaging with the material in a longer way, which might mean a more meaningful way. Now, one reason that happens has to do with voting actions that are taken, which is this next row here. So what is a voting action? So on the Likert side, this is very easy to define. They just go and select a radio button. There's nothing selected. They move to 3. Done. That's an action. It's super clear. But the problem is in QV, you hit those up and down thumbs to get to what you want. So what you really think is a movement from 0 through 1 and 2 to 3 should be one voting action. You don't want to count that as 3 different voting actions, because that was just a representation of the system they're trying to overcome. Now, unfortunately, it starts to get complicated. You know, what do you do when they go up to 3 and back down to 2? And they just do it all very quickly. So in the end, we decided to count that as one voting action. Okay, they may have just accidentally hit the plus button one too many times. The fact that there was so little time between the 3 and the 2 suggests that they probably meant the 2. But then you get things like this, which happen in the data all the time. They move up to 3, there's a long pause, they stay on the same question, and then they move down. So we made the decision to count this as 2 voting actions, that somehow this amount of time here should justify that something qualitatively different is happening. Okay, so when you make those sort of reasonable definitions, these are the voting action totals that happen. So basically what it means is that the Likert people vote on all 10 issues, and then they do one more thing. Maybe they strengthen a vote. Maybe they weaken a vote. I don't know what it is. The QV people do a total of 15 things. And what's interesting, that 15 is not 10 plus 5. Because in QV, if you want to vote of 0, you just leave it. And it just stays at 0. So it's some other addition that might be like 8 plus 7. You know, I really only voted on 8 things. 2 I left alone, so those didn't ever get counted as voting actions. So somehow this is a lot more impressive than just 10 plus 5. And you can see the same results happen when you use the same human being to do the voting. And the reason these numbers of voting actions are higher, obviously, is because of the next line, where we have revisions. Okay, so a revision is when you make a voting action on something that you've already made a voting action on. And you can see that the QV people tend to make about 5 revisions. The Likert people tend to make 1, and you can see how those divide up in terms of, did I make a stronger revision or a weaker revision closer to 0, or did I hold with my vote? Now you can also sort of watch these revisions happening in real time if you want. And some people like to see that. It's more meaningful somehow. So here's how you might do that. You might take all of your, say, 1,000 voters in a methodology and sort of line them up from those that made the fewest revisions to the most revisions. And then you might go take some of them. And here I just took people around the 20th percentile of revisiness and the 80th percentile of revisiness. And I said, I'm just going to go look at you and see what you're doing over time in a survey. And I don't want to like watch you doing all the surveys. So I'm going to come up with a visualization that shows me what you're doing. So here's what a visualization might be. Okay, you can take each person, the horizontal axis will be 0 to 1, from when you started to when you finished the survey. And I can sort of map your actions. Every time you cast a vote, we'll put a circle. Every time you make a revision, we'll put a triangle. And the vertical axis here is the accumulation of all the votes you've cast over time. So it should sort of go up over time, right? You vote on the first one, you vote on the next one, now you have more votes going on. And use the absolute value of the votes. Okay, so they vote a 3, then they vote a -2. So you go from 3 to 5. And what's nice is you can sort of see visually what voters are doing over time and get a sense of how people interact with the 2 different kinds of methodologies. Okay, so here are those vote accumulation graphs for the 20th percentile and 50th and 80th percentile. And there's, you know, somewhere between 40 and 50 people in each of these graphs. And what you'll notice here is there's nothing very exciting about Likert people at the 20th percentile of revisiness. They just vote and they're done. So we have monotonically increasing graphs that are all circles. Okay, and by the time you're getting up to the 80th percent revisiness of voters, you start to see a few triangles. But there's not really much going on. Under QV, things look pretty different, actually. The 20th percentile of QV people look a lot like the 80th percentile of Likert people. You're starting to see some triangles. You're starting to see some graphs that are maybe not monotonically increasing anymore. And then finally, the 80th percentile of QV people, you can see they're taking a tremendous number of actions, a tremendous number of which are revisions. And they just look incredibly different than the other 3 graphs. And one thing that's interesting is to look at what happens sort of at the end of it all. Okay, so you have vote totals at the end in Likert in these big spans. And under QV, you have this big span. But finally, under the 80th percentile, everyone is sort of clustering here around a total of 30 votes cast. So somehow they're sort of die hard to use up all of their credits and fill their bellies with as much voting as they can and sort of spread out their voting profile to its maximum size. And in doing so, they all sort of end at the same place in total number of votes, absolute value of votes cast. Okay, and these Likert people, I mean, how can you say that someone really cares that much when they've cast a total of 7 votes and had the potential of casting 30? Okay, it just doesn't make very much sense here. So something's qualitatively different in these graphs. Another thing you might care about is how often people are just revising these different proposals. So here is a beautiful little graph that shows how people fit into certain bins. So if you just look at the red for a moment, these are people using Likert. And you can see that most people revise 0 proposals out of 10. And then, you know, at one proposal, where about 30% of people are revising 1 proposal. And it quickly drops off. You basically have no one who's revising 6, 7, 8, 9, 10 proposals. But in QV, it's much different, the blue. So here we have people revising 10 proposals is not uncommon. So it's interesting to see like how those proposals distribute over the different, or how the revisions, distribute across the proposals. And you see that people are not just rethinking 1 or 2 things in QV. They're rethinking a lot of things in QV. And if you want just sort of the averages that come from those graphs, the means of those 2 colors That's what these numbers are. So the average Likert voter is going to revise 1 in 12 things. There aren't even 12 proposals, but and the average QV person revises 1 in 3. So it says something quite powerful about someone engaging with a QV survey. 1 out of every 3 things you're going to say, well, maybe I don't really believe that anymore. That's quite interesting. And finally, we'll talk about predictive value and some insights. One thing that often happens, we'll go to politics for a moment. So there seems to be this new trend in politics of dividing people up into these 7 different categories. And people like this because they think it gives you this great fine granularity of understanding the electorate. But that's not actually true when people go and it's time to actually vote. And what tends to happen in practice is all that fine granularity collapses in the voting booth. Okay, and this has been seen time and time again in actual studies of people. So what would be nice is if you had a methodology that actually showed this rather than this. Okay, because this is an artificial construction of academics, and this is what actually happens when people have scarce resources in voting booths, or when they're dividing up money at companies, and they just sort of go rank and file with the second word in the description rather than the first word, or both words, or something like that. So it turns out that QV actually shows this difference. Okay, it reveals what happens in practice rather than what happens in theory. Okay, so on this graph, the top row is how the different 7 demographic groups landed when it came to voting on background gun checks. And the x-axis here is their z-score of the average. Okay, so you can see that the independents here are roughly at 0. Okay, they were in the middle of the pack. And the bottom row is where that group goes to when they use QV instead of Likert. So these are the people that took both. And you can say, well, where did the strong Democrats land in Likert? And where did the strong Democrats land in QV? And if you look up here at the Likert, it seems like we have all 7 of those categories roughly, or 6, we'll say. So there seems to be some credibility, according to Likert, that you really should use all those categories. But under QV, it doesn't look the same way. I mean, these 3 different democratic groups all sort of collapse down to the same point, which is what you actually see in practice. So there's something nice about QV in the sense that it actually predicts what happens in reality rather than some theoretical construct that people like. So this is one value that political scientists might care about in relation to QV. Here's another thing, and I actually think that this is the most valuable thing that I learned in studying QV versus Likert. So it requires a few definitions. First, you have to define what a strong vote is. Okay, and here was the definition of strong vote for this paper. Okay, in Likert, it's using one of the 2 ends, and in QV, it's using this -10 to -3 or 3 to 10. Okay, and this is not an absurd thing to define because the definition is roughly the same across the 2 methodologies. So 15% of people gave a -3 in Likert. 13% of people gave a -3 through -10 in QV. Okay, these -4 through -10 don't exist in Likert. So this just means -3 here. And you can see the numbers are basically identical for this definition of strong vote, which is one reason you might say that's a reasonable term to define. Okay? And you could say, well, it would be really nice if we could understand what's going on with strong voting. Okay, somehow strong voting is what you really care about, or some people care about. It says something about your populace. So there's a lot of strong voting going on in both of these methodologies. Okay, how many people gave 6 or more proposals a strong vote in Likert? A third of people are giving, they care about 6 or more proposals at the strongest possible level of the scale, which is quite interesting. And as you would expect, this number dies out as you demand more and more proposals be given strong votes. But we have 3% of people that give everything on the survey the strongest possible vote, which is like, how could that possibly be? So I would like a methodology that doesn't happen very often. And you can see that QV tends to do about half at these total extremes of the extremism that's going on in Likert. So it sort of holds back extremism. But beyond just holding back extremism, it does something even more important. And that is that it remaps extremism. So let me show you some strong voters. Okay, these are people, these are extremists who gave 8 or more proposals in Likert of 3. So in the Likert methodology, they care about everything. And you can see in Likert, these red bars, this is the absolute values of their votes rather than the directed values, just so the picture is clearer. So here, they're voting all these beautiful red things at a 3. But under QV, you see this beautiful relative importance of ideas that you don't really get out of using a Likert scale. Okay? And I would argue that it's much more meaningful to know the blue data in this graph than it is to know the red data. Okay, here's another example, extreme voter 26. They cared about everything except ISIS, but when they finally had some scarcity in their life, now they don't care about everything. They just want women and taxation and a minimum wage to go their way. And if you think that this is some small subset of people, and I'm just pulling random data here, I'll show you lots of extreme voters, one after another, and you can see the way that people moderate their extremism when QV exists. Okay, there's all sorts of ways it happens. And there are a couple of rare people that desperately try to hold on to their extremism. Maybe they actually do care about everything sort of equally. But you see, there's an example right there. But there are also people that they didn't really care in the way they said they cared, as far as I'm concerned. Okay, so here are lots of examples of these, and you can see that those 2 examples I pulled out were not just artificial examples here. Okay, and finally, the last graph here will be the issue of strong votes and people taking action. You'll recall we had those checkboxes at the end, and one way to think about those checkboxes is as a proxy for them being willing to take action. One thing they notice in political surveys is people say, oh God, I love Obama so much. I would absolutely vote for him, I'm going to do it. And then they don't go to the polls. And the question is, why is there this disconnect? And the reason is, one reason is that the methodology you used to elicit their strength of vote wasn't actually powerful enough to tie it to the thing you care about, which is their action. So what you would like is a methodology that couples a strength of scale and the ability to predict what people are going to do. Okay, so I'll say that at the start that QV doesn't make people check those boxes anymore. If we look at the 3 different kinds of votes, here's the -2 to 2. These, I'm calling these moderate. Okay, you can see the numbers are basically identical on how often people check those boxes. Okay, so there's no overall difference between the 2 methodologies, but there are differences within these vote categories. So if you just say, let's look at strong votes for a second. Okay, strong vote in Likert is nothing more than a 3. Okay, so here's all these people giving a vote of 3, and you can see that 42% of the time, that 3 turns into them checking a box, but only 42% of the time. In QV, a strong vote means something between 3 and 10. And you can see that these 3s in QV, well, they don't really care as much as the 3s in Likert, but you can see that the QV sort of takes that red line and breaks it apart and disaggregates this category, which is effectively meaningless in some sense, and gives you the meaning you would want in that. Okay, so buried in this group of 3 in Likert are people that don't want to take action. And what happens in QV is they go right there. And there are people who desperately want to take action, and they go up there. Okay, so these are some of the findings here. So just to recap, the 4 main things that I sort of get out of this is first, that because QV induces scarcity through a credit bank, first of all, it moderates behavior at a global level. Here's Obamacare, classic W distribution in Likert that basically turns into a beautiful normal curve. Okay? Then it really promotes thoughtfulness at the individual level. You see a tremendous number of revisions, and you see people trying to do a behavior that you don't even see in Likert. They want to use their credit so desperately that they sort of fill out their vote profile as richly as they can. You also, all the extremism, which is a huge percentage of voting, as you recall, maybe 33% of voting you could call extremism if you want, tends to get attenuated. And finally, you have this predictive granularity that gets created through your vote scale. So I'm going to stop there, and I'm happy to take any questions. Yeah?
Well, I guess my first question, which almost gets back to that software patents thing, is are other people free to combine Likert and QV, or have they put some control on it?
Who was they in that sentence?
Say people at University of Chicago want to check how people are happy with the dorms or the food or whatever, and they want to combine a bunch of Likert things with QV. Are they free to do that?
Yeah, so it's complicated. So so Glenn and I have a patent that's currently in the works about this. And so the trouble is that you can't patent, I think you were the one that said it, you can't patent an algorithm. Yeah, you can't do that. Patenting a process requires, you have to fake it, right? You have to do this like whatever, patent every possible variation. So, we have a patent on a technological system that implements this in certain ways. I don't know the answer to that question because I'm not a patent attorney, but I can tell you that there are things in the work that the company's trying to do to get the IP behind that.
Yeah, because if you've got that, and you've got a lock, it seems like you've got a lock on the opinion polls for forever.
One might hope. Yeah.
It may be a fairness variation. So two questions come. One is, I think it would be tremendous to run a further version, which is QV without the Q, which is give people 100 chips, but don't do the square. So both the scarcity, the reallocation.
An LV, you want a linear?
No, and I'm picking linear just for, it's sort of a banal choice. There's nothing special about it. It's that you are simultaneously testing. Give people, so there's no total number of chips in them. I can go the extreme on everything. So one thing you're doing is you're creating scarcity and trade-offs. And then a second thing you're doing is you're representing that quadratically. And of course, part of the properties of the representing it quadratically we know about and are interesting. But as for like, how do people behave? What are the properties of the various things you're identifying? It would just be fascinating to see how much is being driven by scarcity and how much is being driven by curvatures or other things. And you're doing it with people playing and the things moving that they didn't even have to do the math, so I'm not saying it would be easier or anything like that. But so that's the first idea.
Love it.
That would just be interesting to see, to decompose and so forth. The second thing is, it has to do with the sort of the 45 to 75% of your talk by time. You don't have to go show slides, but in that range, there was a lot about this remapping, changing mind, and Likert, they do it once, they do it on average 5 times. And in the entirety of that discussion, the question is like, well, what do we make of that? The first order thing I make of that is, as you said, everyone wants to use their chips. So unless you read all the questions and can do the mental math, which almost no one doing the survey could do or would do, when you sort of get near the end, you're going to either have excess chips or a shortage. And you're going to sort of mechanically, if you want to use all of your chips, you're going to be forced to revise. Now, I will say, the process of being forced to revise might have a nice thoughtfulness feedback. Because, oh, I've got 10 extra chips, where do I want to put them? And that might be telling us more of what we actually want to know. But the mere fact that we get more of these changes in revisions, again, unless people have perfect foresight as to how they're going to allocate, know how the squares work, and know how many chips that's going to leave, they're going to sort of have to jiggle a few times. So just from that mechanical thing, all those slides you were showing us, I would predict. And I don't know how they differ sort of on the thoughtfulness interpretation from what the mechanical baseline would be, just because people don't have the foresight and don't want to leave chips.
Yeah, so I'll just say something quickly. It's hard to understand. People use this software in radically different ways. So some people, as soon as they see the constraint, they take a very timid approach, and they sort of like get a very weak profile, and then they pull it out. Other people are at the other extreme, and they go crazy on the first couple of issues, and then you can watch them pulling back these issues as they go through the others.
Did you, by the way, randomize the order of the 10?
Yeah, so the 10 are all randomized for order effects.
Then you could actually see,
yeah.
Aspects of.
But we have all the, we can watch people doing it basically by replaying in a sense. But people did all sorts of things. Yeah. And so, I had this feeling like you that maybe everyone would just sort of blow it all at first. But that was actually not the case at all.
No,
and you get it.
It's more that unless I looked at them all and did it all in my head before clicking, and you do have some people, these pink people or whatever, who waited 25 seconds before doing their first one, so they were doing some of that. But for most of the people, if they didn't have perfect foresight and figure it out, they'd either overshoot or undershoot. Some would overshoot a lot, some would undershoot a lot, depending on how good their foresight was. And then the more they over or undershot, the more they would have to do revision and backfilling. So any, I don't have thoughts off that yet, but any way you can analyze the data to try to get at how much is 5 versus 1 an indication of how well people just could forecast and had to jingle. And so it would be interesting to see, like if you could look at clicks, how many people sort of got to the end, hit it pretty near 100 on the nose, but then still made 4 jiggles, said, I think I'd like to do, that would be kind of like thoughtfulness. Whereas the people who get to 8 and have none left, and then we see making downward revisions, that would be sort of suggestive of not thoughtful. So the people who did all 10 had 30 chips left and went back and added, I would call that, it could be thoughtfulness, but those are less indicative of thoughtfulness than someone who approximately hit target and then is doing. But that's just one thought, but any way you can try to untangle, because whether it's more thoughtful is fascinating to know, it may well be, but how could we learn that given sort of the differences in structure?
Yeah, thank you for that idea. Yeah.
I have a slightly different take on the revision. In other words, I'm a sucker for surveys. I feel like everything that you said here. I'm much more likely to revise something if it's on one screen. I never go back to previous screens, even if I know, oh, I mistyped something.
Yeah.
I'll just let it fly. So I'm
Yeah.
actually surprised that people on a Likert scale do go back. So if they were all next to each other, I predict people would be more willing to revise Likert scales.
Yeah, so that was a design choice made by other people involved in the project, and I agree that is absolutely a weakness. Yeah, yeah, absolutely. Yeah, Itai.
So this is related to Lewis's question, but it maybe is also some additional motivation for looking at the linear and the quadratic and maybe even doing something else. What's happened here is that there's no sense, if I understood, that the people are participating in an election, and so that they have to think about, pivotality or anything of that sort. And so therefore you don't really know a priori from a rational point of view, how you should expect people to use any given scale or, linear versus quadratic. So that's one motivation actually for doing both, and it's also a motivation for seeing if you can somehow make people think that they are in an election, and see how that affects, do they vote really differently if they think that they're voting in an election as opposed to just, putting, they have a certain number of chips to spend and allocating.
Yeah, so two thoughts. One, as you guys were talking about pivotality all day, I thought, there's none of that in this system. In fact, there's none of that in a lot of systems that happen all the time. That you have no idea how many people are being part of the system. You have no way of calculating anything about what anyone's doing, which is a frustrating thing in some market research because it decreases the amount of information you have. So I totally agree that we don't have those things here. We also, as a second point, we talked about the idea at one point of making a claim that whatever whatever issue wins or gets the most stuff, we will be making contributions to various campaigns to support whatever. Trying to create some sort of thing at the end that made people believe, and it would be true, that we would go put money somewhere based on the results of this, which would make it in some sense feel like an election, voting for where you wanted the money to go.
I just found the part about the Democrats and the Republicans confusing. That looked very interesting, but I didn't quite get the point you were making there. I mean, everything else was crystal clear, and then you had the thing mapping.
Yeah. So again, in reality, if people identify as independent Democrat, when it comes to deciding where to allocate money, for whom they're going to vote, et cetera, they tend to just head toward this mass of people that is the Democratic position.
So in Likert scales, you can't tell the difference between intensity of Democrats.
Well, I don't know what that means. Yeah, like in a Likert scale, these three kinds of Democrats all seem to appear to be quite different kinds of people in how they view gun checks. But under QV, they all map to roughly the same location. And we know in reality that this is how people behave,
Okay, so this-
not this.
So this is very interesting. So this, we've been, in some of our work, we've been thinking a lot about scale use. So we find that there's this big factor. You know, if you do this factor analysis, there's some people who just like to use the ends of a scale, regardless of what the scale is about, and other people who tend to use the middle. And so I think what you're finding here is you're getting how people use a non-incentivized scale, whether they tend to use it all or whatever. And so you can think of the weak Democrat, strong Democrat as how you tend to use a scale, and then you do a similar kind of thing when you get this unincentivized Likert scale. Is that a reasonable description of what kind of thing you're finding? But is that consistent with what you're finding? And then the QV should actually standardize the scale use a little bit more.
People are self-normalizing.
Yeah.
Within QV, but
Yeah.
not in the
Right,
others.
precisely. Yeah, they're self-normalizing.
Yeah.
Although you don't analyze what you would do if you rescale according to these preferences,
Yeah,
which would be, you know.
Yeah, but I think that's the way to think about it, is that there is this scale use difference across people. You have a person-specific tendency to use scales in a certain way across a wide variety of different scales that has nothing whatsoever to do with the substance.
Yes. Or with the reality.
There's
Yeah.
shouters and there's gentle people
So-
who feel.
Okay, this sort of picks up on this conversation and that slide. I mean, I think these results are really neat and interesting. I guess I just want to ask about the interpretation of them.
Sure.
So like, let's take this part of it, for example. You haven't shown that strong Republicans and weak Republicans, or independent Republicans, feel the same way about gun control or gun checks necessarily, right? You've just shown that they feel the same way about gun control compared with abortion and immigration and all the other things they could be spending money on. So a strong Republican maybe feels strongly about all those things and divides credits accordingly. A weak Republican maybe feels weakly about all those things and divides credits accordingly, right? So you've shown that they have the same sort of relative preferences among those various things, but not the same absolute preferences, right? And then sort of at the end when you talked about the various, so I just want to make sure I'm understanding that right. In the end when you talked about the various features of quadratic voting, you said it moderates behavior and it attenuates extremism. And I mean, obviously what you're showing in terms of the voting, is incontrovertible. I guess I want to ask about your definition of moderation and extremism. So in your version, someone who casts, you'd say it's sort of, it's more extremism when more extremism when you're testing, voting 3 for everything, and less extremism if you've got 10 for one thing and zero votes for the other. But of course, in the real world, we don't know exactly which of those cashes out as more or less extreme behavior. It might be that there's someone who's a total extremist on one issue, and so even though they care pretty strongly about 9 other things, they're going to devote all their efforts to that one particular issue, whereas the person might feel weakly about 10 things and split that vote weakly among those 10 things. So, certain types of behaviors become less, it depends a lot on the definition of what extremism, and certain types of behaviors can become more or less pronounced depending on the budget constraints you put on people, right?
Right, okay. So in this, extremism was simply defined as giving a strong vote on a lot of proposals. Yeah.
Not for Likert or for QV.
Yeah, it was about the number of proposals to which you give strong votes. And that's just one definition of extremism. And I like yours too. A lot of people, that's how you would normally define extremism. But when I said that it moderates extremism, it's the reduction in these percentages and moving from this row to this row.
Right. It moderates. Right. I mean, it moderates the
that
number
definition.
of proposals that you're going to vote 3 on.
Yeah.
In a QV system, because
Yeah.
you just have a budget constraint. But of course, that person might vote 10 on something, and that's going, that might lead them to, they might be behaving in a totally extremist way by other sorts of measures, and that they're focusing with laser-like intensity on one issue to the exclusion of all others, and maybe they feel unbelievably strongly about that issue.
Yeah. So, and I think that there were a lot of different definitions of extremism. As I was listening to everyone talk over the last 2 days, I thought, oh, that's different than this definition of extremism. And to your point about this sort of sussing out relative preferences, that's probably exactly true. But perhaps that's exactly what you want. You want to put people in a situation in which the challenge is you have scarce resources and you have to vote among things. And like, it's true in these things, yes. But you would like to see in creating those situations that things happen as you notice they happen in society.
I think you can say something stronger. There are only relative preferences. Anytime you think that you're saying somebody's more intense on everything, you're sneaking in some other thing as a measuring rod for that intensity, and then it's relative to that thing. You know, it might be the outside money, for example, in the pure QB, but there are only relative preferences. You have marginal rates of substitution in kind of the standard case, so that's all we can ever get. You can change the universe of things you're getting relative preferences over, but you're never going to escape relative.
But that's a very strong statement.
Yeah.
You change that universe,
Yeah.
right? Because there could be enormous apathy over.
What do you have for me?
Yeah, well, so one was essentially it's imposing, conservation of certainty or intensity, right? And so it's just, how sensitive is it? So, for example, if you took a subset of those questions, right, that essentially had, high PCA likeness, right, then you'd see a very different conservation over, right? So in some sense, this, what's the sigma algebra? The sensitivity to the size of the sigma algebra seems enormously, because it's relative, but it's relative to the universe of things about which you're concerned. And if this is a very small subset about which you're not concerned, then essentially you're amplifying that. So two other questions. One is, to what degree, I'm just curious the degree to which the self-discovery that's going on versus we're recording preferences, So like I may never have before had a budget constraint, which I was thinking about, this versus that. And then this kind of imposes a completely novel setting in which I actually can't, yell and scream at both protests at the same time, which I might in fact be able to, like in real life. So to what degree do we care about the fact that this is actually constructing, basically people are self-normalizing they're constructing their distribution, you're basically giving them real-time updates about what that distribution looks like. And so, to what degree do we care whether those things are in fact real?
Let me respond to that before you move on. So that is an excellent question. And in some of our early qualitative work, in which we actually interviewed people after they used the software, that was one of the things that came up frequently. That people would say things, well, I didn't really realize that I cared about this issue as much as I do. And so there was some very strong qualitative language, but that's a small n size. And so I say that with a huge caveat of it being a small n size. But that came up a lot, actually. So it's interesting that you brought that up. And I actually believe personally that is in like the top 3 or 4 most important things about using QV in these sorts of real-world settings, is that I think people have really no idea how they feel about things relative and in scarcity. And that's what this does.
To this point, like you suggested at the very beginning, like it just doesn't cost more, And it's like on every measure, it costs more. Like you're discovering new preferences for the first time against normalization of this distribution. People are taking longer, they're spending more time revising. I mean, it costs, so all kinds of good things that's engaging, but it's also costly. That's what engagement is, it's cost, you're investing in it. And so, how do you think about that? I'm trying, because at the beginning you seemed to make a strong statement that it wasn't cognitively costly, or it's just you said something about it simply not being true that it took, but then it seemed like on every measure it took 50% more time, more revisions, more. Okay, so maybe I missed.
You were saying people didn't abandon the survey, the QV survey.
Yeah, because of the costliness. One could argue that it's so costly that everyone abandons, but that wasn't true. Let's move on to your second question. Your second question.
Yeah, that was.
Okay, well, let me move on to some others. Yeah.
So this is sort of really asking about future plans, because a lot of the issues about how people are learning about QV, learning about their own preferences in terms of budget constraints, would seem to be useful if you could have the same people re-surveyed using QV on a different set of issues and then compare them against a naive group. Have you thought about trying to do that? I know it's hard to get the same group of people and resurvey them again in a short amount of time, but it can be done. So have you thought about trying to basically see if you get changes in the number of revisions, how much time people take, and so on, in a group that, say, took a QV survey a week ago and now they take another QV survey, and so basically they know how it works this time?
That's a beautiful idea. We haven't talked about that. Can we get the same people that we had before? I'm asking him. This is Doug von Cohorn. He was the programmer, one of the co-authors.
I think we could talk to some of them, maybe.
Okay. That's a beautiful idea. Thank you for that. We'll think about that. Yeah.
Actually, I had a comment on voting under scarcity. I mean, there's a different version of it that I've commonly seen in contracting, where you're prioritizing requirements for a system, and they say, you know, you can rank these requirements as, true requirements. You must do things that you call requirements, but they're not really our desirements. And they say, you know, you can rank no more than 20% of them high, and no more than 20% of them low, and no more than 60, and obviously no more than 60% of them medium. And so you're not telling them a score, you're just outright telling them the percentiles in order to force them to think of, they just can't rank everything high and demand everything. Right? You're actually telling them the percentages they can do. You know, no more than 20% can be high priority. So you have to really think and prioritize. But if you have to define the requirements, then they'll cheat. But the other one, no one else can now do experiments the way you did that, but they can still do experiments the way the government has been doing contracting. By just telling them the percentage. Which is good to know. As a data scientist, obviously you recognize that each one of these people is a point in 10-dimensional space of what their voting is, and the obvious thing to do with 1,000 points in 10-dimensional space is to cluster them. So, do you have anything on the clusters?
No, we don't have that. And the reason why is that the initial focus of the work had to be comparing methodologies in ways that were approachable by, say, people at companies who don't know any really deep quantitative tools. And so that's why that beautiful idea hasn't happened yet.
Well, this seems like an obvious way to identify voting blocks.
Yeah.
As groups of people who are all voting in the same pattern.
Yeah, well, thank you for that. We'll look into that.
Actually, we're actually working on that in a different context to auto-identify people from auto-identify groups of actors from content units.
That's neat. How much time do we have?
We are done.
We're done.
Yeah.
Okay,
Thank you.
great. Yeah, thanks.